Timers are not only used to monitor time, they can also be used to count for events. What we have seen so far is a timer mode, where the timer register is incremented with every single tick of the internal clock source. It is worth pointing out that you can also gate this timer mode, and the clock will be running only if an external signal is on. That way you can count for only a specific period of time and monitor timing of an event, for instance. In addition to that, you can also count. And your counter register can be incremented by rising, falling, or both edges of an external signal. Finally, you can also support the incremental interface mode that is used to either increment or decrement your counter depending on the signal on the Quadrature encoder. We'll review that in a couple of slides. This input capture and counter mode is used to count for external events. And a general purpose timer is associated with each capture register, and the timer will be incremented each time the external event occurs. You have the possibility to set up which edge you're going to consider, rising, falling, or both edges. And then the counter value can be read at any time, also can trigger interrupts when you reach a given amount of value. The incremental and Quadrature encoder mode are actually fairly interesting. What happened in that case is that you have some external signal that do have this 90-degree phase difference, and your encoder, your Quadrature encoder, will look for not only the different ticks, but also the phase advance or phase delay or advance. And as such, that will trigger your incremental, you trigger your counter to increment up or down depending on the value. What is that used for? It is fundamental to monitor what is the rotation speed of a motor as well as the direction at the same time. And we're going to use that heavily in our DC motor project. The Quadrature interface actually takes two inputs from your MCU and connect that straight to a little bit of logic inside of your MCU that will in turn control your counter. That's a very useful feature, as I said, for a motor interface, where instead of using interrupts to deal with the phase difference between your signals, you will be able to simply control everything in hardware, making things extremely simple to control, to monitor, the speed as well as the position, as well as the direction of a motor.